So from the last video, we derived down the expected general trajectory of the curve, but we didn't really specify which curve it is. We know it's a hyperbola. It's one of the curve of the hyperbolic curve. We got down the asymptote. We know the sort of like how it behaves generally is either one of the curve that we have, but we don't know quite yet. So now we're going to derive and we're going to pinpoint exactly what is it going to do. So before we have x equal to, so let's just write down again what do we have initially. X equal this and y equal to minus 1 plus, I think it's 2 sinh t. So 2 sinh t. Alright, so we have the general curve. We know it's a hyperbola. Now we're going to use calculus. So now we may try to take a derivative of this. Right? The reason why we take the derivative of it is that we want to see how is the horizontal coordinates behaving, and how is the vertical coordinates behaving as t progresses. So there we have it. That's why we gotta use the derivative of each. So we know that this is just 3 sinh t, and derivative of y is just 2 cosh t. Alright. And we know that we might want to draw sort of like a function, like a graph, right? So we know that sinh of t will behave something like this, right? 0, it is 0, and it goes down like that, right? So that's for sinh, and okay. So for cosh, it will be something different. Cosh t at 0, cosh equal to 1, because if you think about it, e to the minus x plus e to the x. I'm just saying in general, not necessarily x. But here, in this case, t. But just in general, we have a cosh equation. When x equal to 0, put 0 in here. Here, there's 1 plus 1, right? 1 plus 1 is 2, or 2 that's 1. So we have it here. When t equal to 0, we have 2 cosh. That is 2. But we don't have to. It's all it is, just multiplying. So we don't have to care about the multiplying. Just draw the general one, right? So this is something general like this, right? So y equal to cosh x. So you know this. All right. So what are we going to do about this? What will this tell us? Well, this tells us something. So now we make like a chart, right? We do like a chart for each of these. What will we have? Well, we have first we have t less than 0. And we say t equal to 0, and we say t is greater than 0. Alright, so now we have x prime t, y prime t. We know when t less than 0, x prime is sinh t. Well, look at the graph. It is negative, so we'll put negative in here. When it's 0, it's 0. Right? And when it's greater than 0, we know that it's positive. Right? And for y prime of t, we know that when t is negative, y prime is still positive, right? And when it's 0, y prime go to 1, which is still positive. Okay? Y prime t is greater than 0 here, positive. All right. So what do these variation tells us? What does these progresses tells us? Well, if we transfer back to xt and yt, we know that if for this interval from t infinitely negative to t approaching 0, we know that x prime of t is minus, meaning that what? Meaning that the horizontal values is decreasing, meaning x is going to the left. It's not going to the right anymore. But that point, whatever the point on the curve that we're trying to find, its horizontal values keep going negatively, right? So it keep going negative. So we go like this, right? So keep going to the left. Keep going to the left. Sorry, this one for x. Alright? For 0, what does it do when it's 0? I mean, it doesn't move anything, right? It doesn't do anything. So you stay there. Okay? So at t greater than 0, you know, it's positive, meaning that whatever the point is at that particular time, whatever the time is within the interval from 0 to infinitely positive, whatever that time is, that point will have its horizontal value keep going to the right. That instantaneous rate of change of that point in the horizon keep going to the right. So we have it going to the right, right? All right. For y, same principle approach, but instead of going for left or right, go up or down, right? So for yt, if this is positive, meaning it's going up. If it's positive, meaning it's going up. Okay? Here 1 is still positive, that's why we put positive. Right? T greater than 0 positive, right? So positive going up. So keep going, increasing up, alright, for the horizontal component. Alright, so this tells us really good at how should we expecting our curve to be. Alright, with all this information, previously, what do we have? Previously, we have something like this. This is just a rough sketch. We have a hyperbola that acts like this, right? One go like this and one go like that, and we may have like an asymptote, right? Alright. So now, if you're trying to mimicking this process, this whole process, which curve will act the best? Well, let's try. Let's try with this curve first, or this one. Okay, let's try with this curve first. You see that x go to the left at t is infinitely negative. All right. How do we know when t is infinitely negative? Where do we even start, right? What are we trying to do? So the first thing you might do is try to plug in any negative t and see where it goes. For this case, we may plug in t is minus 1, for example. T is minus 1. Alright. Well, if t is minus 1, you plug in here, you know, cosh is always positive. You plus 2, that's even positive, right? So x is always positive, t is negative. But if you look at this curve, when you put in t is negative, there's no point here, because x is always negative, right? There's no point to start on this one. So at that first test, you know that this curve is not even a candidate. I think we know for sure that it's got to be this one, but we cannot go for sure yet. We've got to check everything, right? Be careful about it. So, well, we know that we've got to start here, somewhere here, right? Because x is positive. What about y? Well, t is minus 1. Since minus 1, that's minus, right? So minus and minus, that's even a minus. That's even more negative. So y can be down here. X is over here. Y is down here. So they perfectly match. Okay. So okay, we know where we start. Now let's just try to mimic this process and see if it works exactly the same way that calculus tells us. All right. So now we have. So now we have that the x prime t, this is minus, right? So it's minus, so it's going to the left. You know, if started from here, starting from some point over here, t is, for example, you start with t minus 1, minus 2, and then t minus 1, and then t equal to minus 1/2, and t minus 1/4, something like that. And you know the exit goal is going to the left. So it is, right? It matches. So it starts somewhere here, it's going to the left. So you keep going to the left like this, and what does y do? Y is going up, right? So it does. Keep going up like this. Alright, so until it reaches a point, so in other way, from negatively infinity, you keep going like this, along asymptote, keep going, and then it reaches this point, this sort of the origin or something, and then this point is stopped, right? The horizontal component is stopped moving, meaning that it's about to change its direction horizontally. See, the vertical is still going up, but the horizontal direction is about to change, right? So it's like a particle is when it's about to turn or to make a curve at that peak or at that local max or the local extrema point is it stays still, right? So meaning that it's zero. This derivative is zero. Its instantaneous rate of change is zero. Therefore, it stay there. All right. But the y is still going up. So you see, it stay there. The horizontal, it doesn't move, but the y is still going up, right? So you draw like a tangential vector or like a line there, like an equation. The tangential equation is going straight up. Well, if you pass that point, what happened? If you pass that point, meaning the curve go this way, right? So therefore, the x will keep going to the right, and the y is still going up. Well, you see, so that's why it's still going like that. So you know that this is the curve. We have the formula, the hyperbola formula that we derived earlier for this curve, and we know it's asymptote. We know its origin, and we know its trajectory. Therefore, we define it. That is to be that curve, which is defined by this parametrization. All right. Thank you very much.